So before moving forward in the video, I have an important announcement for you. So if you're somebody who is actually willing to learn advanced backend technologies, then this is going to be the right platform for you. So at Algocamp, we have launched our new flagship Lambda 4.0 Advanced Live Backend Development Batch, in which you are going to learn advanced backend technologies including Fastify, Express.js, AWS, Mongo, DynamoDB and whatnot. This is going to be a power-packed course in which we are going to take you from the very scratch, very basics of backend technologies to the very advanced level by building a lot of interesting projects. We are going to build projects like Code Sandbox Clone. We are going to build streaming app which will include recorded movie streaming plus live streaming as well. We are going to make applications like booking.com backend, which is going to help you understand transactional capabilities, integrations of payment gateways and many more. All the important projects that we are going to cover in the course is going to be listed here, and this is going to be an absolute live course where we are going to take live classes, right? And in these live classes we are going to do hands-on coding experience to learn all the important advanced backend technologies. You already know that backend is something that every important application needs, and you can actually excel your software engineering career with these backend tech in the Node.js stack. So what are you waiting for? All the important links, the complete syllabus, curriculum, all the details of the course is present in the description section below. You can use the coupon code coming up here to get maximum discount off on the current price. I'm really excited for the course. I hope you guys are too. And now let's get back to the video. Now we know that how exactly asset properties work, how exactly transactions and everything work, right? And we also tried to understand about the isolation levels and everything. But again, there can be problems of race conditions, right? What is a race condition? When two different entities try to access the same resource, two or more different entities tries to access the same resource, that is called as a race condition, right? In order to avoid race conditions, we can do multiple stuff. For example, of course, we can make our isolation level serializable, right? That too will automatically make everything go in a very serialized fashion, right? Apart from that, let's say if our case is not of updating anything, or two different transaction might not be updating anything, then even the read committed state something can help us, right? If you remember this one, repeatable read state, because the only problem it gets is the phantom read problem, right? So there are different serialization levels that isolation levels that we can use. But apart from that, MySQL also provides locking mechanisms, right? MySQL provides locking mechanisms using which we can actually avoid race conditions, right? You can even use these locks in order to avoid the race condition, right? Race condition for our case will happen if multiple transactions are trying to access or manipulate same data at the same point of time. Okay, and few of the locks that MySQL generally provides is shared locks. What is a shared lock? This allows multiple transactions to read data at same time, but restricts any of them from writing. Okay, so multiple transaction, if they have to read the same data using a shared log, they can read the same data, but none of them can actually write it, right? That's the concept of shared logs that MySQL provides. Also, one very important thing, if you remember when we were talking about our isolation levels, the isolation levels are internally dependent on these locking mechanism. If you remember on Wikipedia, when we were reading that, okay, what is the definition of this isolation level, then they were specifically mentioning that this isolation takes a read log and the write log and so on, right? If you don't remember, I'll just quickly show you. Isolation wiki, right? If you carefully see, for example,
isolation levels, right? For example, if you see anyone like read committed, so in this isolation level, if there is a lock based concurrency control DBMS, so these isolation levels are internally dependent on these locks, right? They keep a write lock until the end of the transaction, something like this, right? So these locks that we are going to talk about, these isolation levels will be internally somehow dependent on these as well, right? The second one is exclusive lock. The second one is exclusive lock. What is an exclusive lock? This prevents transactions from reading or writing the same data at same time, right? So for example, if one transaction has taken an exclusive lock, the other transaction won't be able to actually read or write anything on the same data at the same point of time until or unless this lock is removed, right? The third one is intent locks, right? This is used to specify that a transaction is planning to read or write a certain section of data, right? So you can actually show intent locks that or use intent locks in order to like signify that there will be a transaction that might read or write this particular section of data. So if there is an intent lock already going on, you might want to avoid reading or writing the same data at the same point of time. Like it will be your choice. But the fourth one is going to be important, and most of the time this is going to be most helpful as well. That is row level locks. Now all of the other locks that we were actually discussing are going to actually put a lock on the generally on the tables, right? This is going to be a row level lock, right? This allows transactions to lock only a specific row, right? So let's say if there are two different people making two different bookings, row level locks are not going to affect them. If there are two people who are trying to make the same booking for, let's say, the same flight at the very last moment, something like that, then row level locks will actually come into place for them. So row level locks are going to be a bit efficient than the other exclusive lock or shared lock, because exclusive lock is going to lock the whole table altogether. That can be a bit expensive, right? So if you actually talk about things with respect to MySQL, so generally people consider MySQL to be a MVCC database. What is MVCC? It is multi-version concurrency control database, right? And generally MySQL is compatible to allow multiple transactions to read or write to same data without much conflict, right? So MySQL, using all of the strategies like isolation level, then internally locks, is capable to allow us multiple transactions that can read or write the same data, and it might, most of the cases, it won't cause much of a conflict. Now here you might be having a question, how? Right. So what happens is every transaction in MySQL sort of captures the data it is about to modify at start of transaction and writes the changes to an entirely different version of data. So see, MySQL is smart. MySQL knows that there can be concurrency related problems. So if let's say two transactions are there and they are trying to update some data or modify some data, then it's not going to actually go and update the data in the same table at the same point of time. What it will do is it will write the changes entirely in a different version of data. Maybe it can maintain somewhere it as a copy somewhere in the disk or somewhere else, however it manages, right? This allows transaction to continue working with original data without conflict, right? So this mechanism that internally MySQL uses helps us to actually make transaction, two different transaction, to work on the same data without conflict, because they are going to maintain absolutely different versions of data, right? So until or unless we reach to a very conflicting situation that, okay, at this point of time we should do some manual checks as well, most of the time MySQL will handle all of your transaction and concurrency related changes very efficiently. So I'm talking about that if you are involved in a booking system, in booking system there can be multiple cases of race condition. There can be different ways in which race conditions can occur. Two people might be booking the same room, same flight, same movie, a lot of things, right? And in booking systems, handling these race conditions becomes extremely important. So in order to handle these kind of race conditions, what we can actually do is we can actually implement two different kind of mechanisms, right? We can actually implement two different kind of mechanisms, and everything is going to be given to us by MySQL, like the whole possibility is there. We can implement a pessimistic concurrency control, and we can do an optimistic concurrency control. Now let's talk about both of them. What is pessimistic concurrency control? In pessimistic concurrency control, we try to avoid these race conditions in a database by locking the data, right? We can use the mechanism of locking, or we can use our isolation levels, right? And these things can ensure us that at one point of time only one person is actually accessing the data, which can cause the race condition, right? So there are multiple ways. For example, one way is to set our transaction serializable, right? This is a good way in which you can actually make sure that two transactions are gonna occur one after another, right? Apart from that, you can actually implement locks. So we can get a row level lock. If let's say for our use case we are only going to affect a row, we can actually take a row level lock, and it is very easy to take row level locks for MySQL, right? You can write a statement like this: select star from table, where you will write a condition based on which you can actually signify a row, right? And then you can write something like for update, right? This statement, what this statement is going to do is this statement is going to put a lock on the row, right? That is going to be accessed while making an update. After making this statement, you can try to make an update, and this will actually put a lock on that particular row. As simple as that, right? As simple as that. Or of course, you can actually put serializable conditions where you will make your transactions to go one after another. This is pessimistic concurrency control. Then there is optimistic concurrency control. What is optimistic concurrency control, right? In optimistic concurrency control, what we will do is we can put manual checks for conflict, right, before committing the change, right? For example, there were two transactions who were trying to book a flight ticket, and that this was the last flight ticket that was available. Let's say one transaction completed, the second one is still going on, one transaction completed and committed. Now this transaction was also accessing the same single flight ticket. Let's say I will allow this also to book the ticket, but before committing, we can actually put a check, or before actually updating, we can actually put a check that only update if and only if the number of seats are greater than what do you need, currently available is greater than what do you need, and the total number of seats that are booked in the flight is definitely or let's say total number of remaining seats in the flight is not less than 0, right? Just think about it. If let's say there are 2 seats left in the flight, there is one transaction 1, there is another transaction 2. I'll say that, okay, if transaction 1 also takes this ticket, I'll do a -2 on the table. If transaction 2 also takes this ticket, I'll do a -2 on this table, right? And let's say this transaction 1 got committed. Transaction 2 is about to commit, but before committing any transaction, I'll keep a check. I'll check that how many seats are left. If both of these transactions will get applied, then the remaining seats will be what? It will be -2, not -4, it will be -2, right? Because let's say this transaction got applied, it will become 0. This transaction got applied, it will become -2. And if the total number of seats is less than 0, I will roll back this transaction, that this transaction should not go forward, right? In these kind of conditions, or in these kinds of optimistic control, we should always keep in mind that we should never update something like update seats to be equal to 2, not something like this. We should always use things like increment or decrement, that whatever was the last number of seats, do a -2 on that. Whatever was the last number of seats, do a -1 on that. Because if all of the transactions will be resolved, then at last this will be consistent, because whatever the seats, you applied -2 and -1. It was expected that if there are only 2 seats and you will try to do a booking of -2 and -1, where one person is booking 2 tickets, one person is booking 1 more ticket, one of the transactions should fail. If this transaction goes first, then this transaction should fail. If this transaction goes completely first, this transaction should fail, right? But if you will do something like set seat is equals to x minus something, so this might be a problematic situation, right? Let's say you say x minus y. If you say seat is equals to x minus y, initially x was 2. Now let's say if this transaction goes through, you are going to say 2 minus 2 0, right? And then if this transaction goes through, you are going to say 2 minus 1 is 1. And there can be a case that both of them actually read the old data, which was 2. So for both of the transaction, these things looks perfect, right? It is greater than or equal to 0, it's not less than 0. So that's why a lot of time you will see for these kind of transactional capabilities, you will see people doing more increment decrement rather than setting the data directly, right? Now what we are going to do, we will definitely put this checks manually, because we want to be safe, but we are also going to use this serializable isolation level, right? And try to implement our flight booking service. If we have enough time, I can also show you that how you can actually use that. It's nothing. Before we actually have to make an update, we just need to execute this particular query and things should start working absolutely fine. Now let's see how our booking mechanism is going to work. If you carefully see how our booking table looks like, in our booking table, we need to have a flight ID. We need to have a user ID. This will be given to us by the users. This status we are going to set once we create the booking. Number of seats, that how many seats we are going to book for a particular user, is going to be given by the user, that how many seats they want, right? And then there is a total cost. Total cost we can manually compute. Now you can see, in order to compute the total cost, we need to get the cost of one flight. So now it's a good time to actually open our flight service as well. Okay, so if you actually go to flights, then you will realize that every flight was having its own price, right? So if let's say somebody requested 2 tickets and one ticket was of 3,000 rupees, 2 tickets will become 6,000 rupees. So based on that, you can actually set your total cost here. And every flight has total seats as well. This is the total number of remaining seats. So whatever number of seats you are going to request, we will subtract that from total number of seats, right? We will reduce total number of seats by that particular number, right? Okay. And we will try to do an increment decrement rather than just doing an update equals to or set kind of a thing, right? And that's how things are going to work. Also, both the flights and booking details I have kept in a single same database, right? The database is same, right? I have not kept two different databases for for both of these services. There can be a case that you have two different databases for both of these services, but we have a very simple use case. I will implement one more service. There we will be having a different database altogether, right? Now you can see if that's the case. Now what do we have to do is inside our booking, when we will get a request of post request of slash bookings, we are going to get a request body. Inside that request body, we will get a flight ID. We will get a user ID, whosoever is willing to book the flight. Then we will also get the number of seats they want to book, right? This will be the incoming request. Now based on this request, once this request comes to our controller, right, this request is going to hit first of all our middleware, and from middleware this is going to hit our controller. From controller I will route this request to the service, and this is what? This is the booking service layer. This is the booking service layer. So I'll go to the booking services service folder. Now here inside the service folder we have access to the flight ID, user ID, number of seats. I don't need user details for doing the booking. I just need the user ID, but I need the flight details in order to book the corresponding flight. Now inside this microservice, you can see I don't have any files or any controller or services that can help us to give us flights. What we have done is we have a separate microservice, which is a flight service. Anyone can actually make a HTTP request on this flight service, right? It has a bunch of APIs for flight exposed. Anyone can actually make an HTTP request on this flight service and actually get the detail of a flight. So that's what we are also going to do. This booking service is actually running on a different server. This booking service is a different server. Most probably this is running on what? Port 4000, right? This is running on port 4000, right? Or you can assume that some other IP address it is deployed. And then there will be our flight service. There is our flight service, and at least for our local case, it is running on port 3000. What we are going to do, this is the time where we have to do inter-service communication. This is one service, booking service. This is another service, flight service. These two services need to communicate with each other in order to actually create bookings, right? Because in order to create the booking, I need the flight details. Once I do the booking, then I need to go and also update my flight's remaining seats, right? So there will be some fetching of data and some update of data, both of them going on from the booking service. So that's where inter-service communication actually helps. Now, if there are two services, depending on situation to situation, inter-service communication can occur in different manner. Let's say this is service 1, this is service 2. The simplest of them can be service 1 makes a HTTP API request, REST API request, and it receives a response. This is one way. Another way can be that you actually make an RPC request. You make an RPC request and then you get a response. I'll talk about RPCs later, right? Apart from that, let's say there is a situation that service 1 has to initiate a request, but service 2 doesn't have to respond immediately. And the scale of service 2 is not as high as scale of service 1. Then we can even introduce process queues in between. But more about that when we will actually implement our notification service. For our current situation, that is the booking service and the flight service, booking service is going to make an HTTP request to the flight service, and that's going to give us an HTTP response. And of course, one of the most famous libraries to actually make an HTTP request in Node is Axios. We're going to use Axios in order to make this corresponding request, right? So let's try to do that. So now let's first of all get our few requirements set up. First thing first, we need Axios. So I'll go to the terminal. I'll say npm install Axios. Axios is going to be the library using which we can actually make HTTP requests. You can see we have Axios with us. Okay. Now, if you carefully see, Currently, we only have two APIs, that is to create a flight and get all flights. We need two more APIs. One using which you can actually, I would say, get a particular flight details, and the second one using which you can update a particular flight and specifically the seats. So let's try to implement that. We are going to implement that in the flight service. These things will be implemented in the flight service. Once this is done, then we will initiate the booking from the booking service. Okay, let's try to do that. So let's come to our flight service. We have get all flights and create flight. I'll implement one more function, async function, get flight. This is going to give us a flight ID, and based on this flight ID, we are going to do most of our stuff. Okay, so we can actually get it from somewhere else. For example, this get airport can help us. Okay, I'll say we have a flight repository dot get ID. This is a flight. Okay, get flight. If the flight won't be present, we are going to just say not found. Okay, 404 not found. So we have added the get flight. We already have our repository set up for that, so we don't need to bang our head on that. You can say in the controller for flight controller, let's come to flight controller, and then I'll again copy this from airplane, that is get airplane, something like this. I'll copy paste here. This one is a simple CRUD, so I'll say slash flights slash colon ID, right? I'll say get flight. I'll say request dot params dot ID for flight service dot get flight. This is going to return us a flight. That's it, and we are going to say get flight. Okay, and then let's just register this on our routes. Here we go. Copy, paste. We'll say slash flights slash colon ID. So we'll say colon ID. Instead of routing the request to get all flights, I'll say get flight. And that's it. Let's run the server. Npm run dev. This is running on port 3000. Let's open Postman. One thing you have to keep in mind is we are in a microservice based, I would say, project structure. Here, this booking service will be deployed on a different server. Flight service will be deployed on a different server. We can't do a library call in between them. We can't use flight controller functions as a library call inside booking service, because when we will deploy them, they might be deployed on two different machines altogether, right? Because, and why we would want to deploy them on two different machines? Because their scalability factor might be different. We want to scale the flight search service more and flight booking service not at that particular level. So their scalings can be different, right? So we should maintain them properly separately. That's why an inter-service communication is going to be the only feasible way. The simplest meaning of microservices is that every service will take care of its own use case, right? In a monolith project, when you talk about a monolith, there are two types of structures that you can project. One is a monolith, one is a microservice. In a monolith project, what happens is you put all of your code in one repository. Now, in our case, if you would have to implement a monolith, then the booking service and the flight search service, all these details would have gone into a same node project. In that case, both of them can communicate within each other like a library call, no problem. But the problem comes up when, if let's say there is a problem with the booking code and the server crashes. Due to that, the whole server will crash. User will neither be able to book a flight nor be able to search for a flight, because everything was present in the same folder and the whole server is gone. Second thing, if let's say we want to specifically scale our flight search service, we manually have to scale the booking service as well, because both of them are very tightly coupled in the same project. That's why we segregate based on what is the actual use case. all these services into different microservices. Microservice is a smaller service. It's a smaller project that handles a very particular use case, right? Now, what will happen is if there is a issue with the booking service code and the booking service goes down, the flight service is still up because that's a different project that's running on a different microservice, right? Apart from that, there won't be tight coupling, right? That means if you want to specifically just scale that my flight service should run on 10 machines at all point of time, but my booking service should run on 3 machines until or unless there is a lot of scale or there is a lot of load coming up. These kind of segregations you will be able to do. That's what microservice architecture means. Now, in order to communicate between microservices, you might use HTTP calls, RPCs, or maybe some other mechanism. For example, you can, if you just want to publish some events, you can use a pub sub architecture and use some messaging queues there. Now we already have implemented our flights get flight service. Let's see if it is working fine or not. Let's go to MySQL. Let's say select star from flights. We have a bunch of flights, so we can actually test it. So localhost 3000 /API /v1 /flights /2. And you can see we are getting the flight details. Looks perfectly fine to me. So now git add all, git commit -m, added, get flight API, git push. Okay, cool. Now we will be implementing one more API. We will be implementing one more API inside our flight service. This time, what do we want is we want to actually decrease the number of flights, the number of seats available inside a flight. Okay. So what do we have to do is, you can see this is the flight repository. We might have to implement a function here, which can actually help us to decrease the number of seats in the corresponding flight. Now let's see. If you Google about Sequelize, there are dedicated increment and decrement solutions. Okay. So you can see you can actually do a model.decrement. So there is a function model.decrement. Okay, let's directly go here as well. Let's see incrementing and decrementing a value. So you can see if you have to execute a query like this, where you increment the age by 2. So instead of, like, just think about it. If let's say previously the age was 5, you have to increment by 2. One way is update table set age is equals to 7, where ID is equals to this. So previously it was 5, you are manually setting 7. Other way can be to increment it, that update table set age is equals to age plus 2. Whatever was the age, just do a plus 2 to that and then execute, right? That's what's going to happen. So we are going to use this increment and decrement function. For our case, we have a decrement instance method, right? That we can actually use, right? See, it does set column is equals to column minus x, and that's better, right? Instead of just saying column is equals to y, better do column is equals to column minus x, because at last then what will happen, your final set of total transaction will actually implement well. Okay, so now we're going to implement this. So I need a function here, const, I would say update, let's write like this. Let's see what's the async, update remaining seats. Now this is not going to come from CRUD service because this is a custom implementation that we have to do, right? We have to update the remaining number of seats for the corresponding flight, right? Okay, cool. So if you have to update the number of seats, I will be passing a bunch of parameters. The first parameter that I will pass is a flight ID, that for what flight you want to update the seat. For example, when you will do cancellation, then if person has cancelled a flight, then the number of seats, number of remaining seats should increase, right? That should increase. So we'll pass a parameter seats, that how many seats to affect, and then I will pass a parameter decrease, which will be having a default value as true. Okay, or just say DEC, right? Default value true. If this parameter is true, then we are going to decrease the number of seats. If this parameter is false, then we are going to increase the number of seats. Now what's going to happen? We are going to say if decrease, then something else something. We'll say const response is equals to await flight dot, let's see, decrement. Okay, flight dot decrement. Then you have to pass which parameter to decrement. So in our case, we have to decrement total seats, right? Decrement total seats, and by how much? By seats. So we'll pass an object by seats, as simple as that. And then you are going to return response. If that's not going to happen, if this is not decrease, then you are going to say increment. You're going to say increment, as simple as that. So now we have implemented our update remaining seats. Now we should come to flight service. Okay. Here we will implement a function, async function, update seats. It's going to get a data object, incoming data object. I'll put a try catch. Okay. Now we have to update a certain set of seats for a corresponding flight. Okay. How can we do that? We'll say const response is equals to await flight repository dot update remaining seats. We have to pass data dot flight ID, right? Then we have to pass data dot seats, and then we have to pass data dot decrement. Okay, as simple as that. And then we return a response. Otherwise, for the time being, I'll throw an internal server error. Cannot update data of the flight. Okay. Cool. Right. We'll see if there is any other exception also coming up, but for the time being, and we'll also do a console.log error to just see if error is coming up. Okay. Update seats. Okay. And then we are going to go to the controller. We are going to say const, or I should say async function update seats request comma response try catch. We'll say const response is equals to await flight service dot update seats. Then I'll pass a data object where we will say, let's see, what does it expect? It expects a flight ID. So request dot body dot flight ID. Then it expects a seats parameter. Request dot body dot seats. And then it expects a decrement parameter. Request dot body dot decrement. This decrement parameter is non-mandatory, because if, let's say, if somebody doesn't pass it, then it will be undefined. We will pass undefined here, and then inside repository, if decrement is undefined, that means it's going to be false. It will do a type coercion here, right? As simple as that. Okay. Then if everything went well, we'll say success data is response. Otherwise, if something went wrong, that's what you have to do. Update seats. Let's export update seats. And that means that flight ID and seats are mandatory parameter. If these are mandatory parameters, let's go to flight middleware and validate it. So I'll say function validate update seats request. Okay, we have to validate it. Request response next. We'll export this as well. Okay, and let's copy paste from above, paste it here. Now in our case, if request.body.flight ID is not present, then we will say something went wrong while updating flight, and we will say flight ID not found in the incoming request incorrect form. And then apart from that, we will say seats, that seats not found in the incoming request in the correct form. Otherwise, we will call the next middleware. That's it. We will go to routes, flight routes. We will register one more route. Now I'm going to keep the address like this, that if somebody makes a call to /API/v1/flights/seats, right, and we will make it a patch request, right? So we'll say router dot get slash seats, right, and then we can say flight middlewares dot validate update seats request, flight controller dot update seats, right? As simple as that. So if somebody will make a request to /flight/seat as a patch request, we will first of all validate the request and then only go and update our seats. Now let's see if everything works well. I'll do npm run dev. Looks good. Now I'll say /flights/seats. I'll make a patch request. Okay, and I believe one small thing we should do. I should not have the flight ID to come in the request body. That's bad, because we can do something like this. We can say :ID /:ID as seats. So we can actually say /flights, and then whatever is the flight, I will pass the flight ID here. And then I will say that I want to update the seat of these flights. That means in our controller, this is a better, I would say, convention to go for. I should not get body flight ID from body. I will say request.params.id. And same thing in the middleware. Now you don't need to check for flight ID because it's mandatory to send it. Right? Otherwise the route won't be found. Yeah, that's better. That's better. So I should take a flight ID. Let's see. Flight ID is 2/seats. And then in the body, I'll pass seats. So total number of seats are what? 120, right? I want to, let's say, decrease 5 seats. I want to decrease 5 seats. Let's see if the server is up. Yes, server is up. Localhost 3000. Send. Okay. It says something went wrong. Let's see why. /API/v1. Oh, sorry. This should be a patch request. It's a get request. I have mentioned it should be a patch request. Send it again. Okay. Now it says something went wrong. Cannot update the data of the flight. Okay. Let's see what happened. It says missing where attribute in the options parameter. Assertion error. Let's see. Oh, I got the point. Where is the issue? So if you go to flight services repository, flight repository. Now I just said flight.decrement this. Now decrement by what? Decrement by what? Like, sorry, decrement. We have not mentioned what to decrement. I just said flight.decrement, right? but what to decrement, I have not said that here, right? So let's see. We have to first get this flight object and then do the increment decrement, right? You can even see that here in the Stack Overflow solution. You can see on the object we are doing increment decrement, right? So technically we have to first of all do one thing. I'll say const flight, and that we can actually do outside because that's going to be common. Const flight is equals to await flight dot find by primary key flight ID. Okay, that was missing because I just said flight model dot decrement. Flight model won't work. We have to actually get the flight object, right? Which object to decrement, and then I will say flight dot decrement, flight dot decrement. This is actually the flight object, right? As simple as that. Okay, let's try again. Let's try again. Send. Boom. Now it says completed the request, but it has not updated the total seats. Let's see why. Let's see why. What query it executed. So it said flight set total number of seats is equals to total seats minus 5. This. Okay, it looks like it made the update request. Okay. If I do select star from flights, and if you carefully see total number of seats, it is 115. But we are getting an old data. We are getting old data here. How can we get new latest data? So you can see when you actually decrement something or increment something, whatever is the response, it is going to return you the old flight object only. That means what you can actually do is you can actually remove that from here. We don't need to have the response altogether. We don't need to save this response, and instead, once you have made an update, you can say await flight dot save. That is, this flight object will be updated with the latest data. It won't just execute the query, it will save it in the flight object as well, and then you can return the flight object. As simple as that. Okay. Now if you go here, let's first of all see how many seats do we have. Currently you can see there is 105 seats. I want to book 10 seats together. Let's say I want to decrease 10 seats, not say book, decrease 10 seats together. So slash flight slash id slash seats with a patch request send. One second, did I not save it? It got executed. Interesting. So as per our observation and as per I googled, this plain true and returning true is not gonna work here, right? So technically what will happen is whatever you do, you are eventually going to get the old result only because increment decrement doesn't support it. There is one way that you can actually do is you can use something like a sequelize.literal. That might help you because now here in this kind of a query you can actually pass returning true and plain true, but I believe we don't need that. I guess we can just return the flight object altogether, right? Cool. So I believe the API is working. Let's open one more tab and copy this, paste it here so that we can just directly do the get request from here. Patch. Let's decrease 10 more values, and if I do a get request here, get request, so you can see we have 65 total seats left. So decrement is working, right? Let's try for increment. So I'll say decrement is equals to false. If you pass decrement is equals to false, then technically it should increase the seats by 10. So technically we have 65, it should become 75. Send it. Okay, see, this is not working well because we are still decreasing it only, right? See, it's still decreasing it. That's not good. Let's try to debug why is that coming up like that. So let's go to our flight controller. Let's print request.body. Okay, we are passing decrement as false. Oh, my bad. So technically, if you go to the service, here I've said, not service, repository, that if there is decrement, then we will do this, otherwise we will increment, right? Okay, yep, cool. So let's send it. Let's see what comes in the log. Okay, decrement comes as false. Right? And you pass it to update seats. Pass it to update remaining seats. Let's see what is decrement coming as. Console.log DEC as DEC. Okay, let's try again. DEC is coming as false, but if you check type of DEC, it's a string, right? So instead, let's change the query, like let's not pass a string, let's pass 0 or 1. If you pass a 0 here, right, then okay, still it is decrementing. Let's see. So what's happening is, if you send anything in the form of a string, for example, you send 0, or let's say you send false, it comes as a string. Now, Boolean conversion of a string with some content like 0 or some content like false in JavaScript will lead to what? It will lead to a true the value. Because what are the falsy values? Empty string, undefined, null, and all of these. So if you go to ECMAScript docs, let's open the docs. I guess it's empty string, null, undefined, false, number 0, number -0, right? These are 6, 7 values. If I remember, 2 Boolean. Okay. Two Boolean. So undefined null, Boolean false, NaN plus 0 minus 0. An empty string. If a string has any content, then what will happen is it will be actually true. So what we can do, we can actually do a parseInt here, right? There is a function parseInt. You can actually see it converts the string argument to an integer argument. You can see that here, right? So if let's say we do a parseInt on a 0, it will give you a number 0, and that's what we want. So what I'll do is I'll say parseInt of decrement. That's it. Now we don't need any of these. It should work absolutely fine. So we are trying to increment this time. Okay, so increment this time, because decrease is going to be false. Send it, and you can see it increased, and I am confirming that via the query as well. Plus 10. Okay, as simple as that. So again, keeping type coercion in mind helps us a lot while writing JavaScript, and we can see our update remaining seats API is working absolutely fine, right? Okay, now one simple thing that we would like to do is that if let's say we are going to update seats for a particular flight, we might want to put a row lock here. Why a row lock here? Because if you carefully see, then there will be 2 simultaneous API requests that can come up, and both of them might want to decrease the number of flights, right? Technically, we would like to avoid that, and in this case, we want to implement a pessimistic concurrency control, right? And this is not a complete transaction. This can be a part of a bigger transaction. This is not a single transaction, right? So just to keep things safe, we can actually write a raw query, and I'll show you how to write that raw query. So I'll say we need that sequelize object. We already have that sequelize object. So you can say await sequelize dot query. Okay. You can actually go there and actually see for raw queries. Okay, so you can see you can do actually SQLize.query. Let's first of all do a normal raw query. Let's say select star from flights. Let's do something like this. Okay, let's increment. Let's see what queries do we execute. We are on port 3000 and one second. Oh, sorry, I did the get request one. Did I? Yeah, I did the get request one. Let's see this one. Let's send it. Okay, it says SQLize.query is not a function. I guess I know why is that. Because I need to get the whole SQLize object somehow. I guess we need the whole SQLize object. So in order to execute this query, you can see if you directly use the SQLize capital S object, it won't work. What instead you have to do is you have to get a DB object that get returned from your model's index file. Right. And then on this DB object, there is a SQLize object using which you can do SQLize.query. Let's try now. Let's send it. And now if you see, it's doing select star from flights. Right. It is executing select star from flights. And now what do we want? We will say select star from, and let's do something like this. This is the flights DB. So select star from flights, right? And let's write it like this. Select star from flights where now the condition will be for this corresponding flight ID, right? So I'll make a raw query in the form of a templated string where now you can see flight.id is equals to 2, right? So you can say flight and we can flights.id is equals to $flight ID. Okay, and I will just write one more condition for update and put a semicolon here. Let's see what happens. Now if I send it again, it says select star from flights where flights.id is equals to 2 for update, right? And let's see if it's a correct query or not. If you execute this query, you can see this query happens, right? And what this query is going to do, this query is going to put a row lock for us for any kind of update that we want to do. One thing that I don't like here is this is a raw string traveling here and there, right? I definitely don't like this. What could be a better way to go for is inside your repository, you can write a new file queries.js and you should write all of your raw queries somewhere at one place. Okay. And it should be queries. Rename. Okay. I'll write a function. Add row lock on flights. I will say return this and this will get a flight ID as a parameter. I'll say module.exports add row lock on flights. Okay. Then I'll go to flight repository and then here I will say const require /queries. From queries I will take one, add row lock on flights. This is a function which will execute as a string, return as a string. I'll just call it. Okay. And that's it. Here we go. If you run it again, sorry, server is down, I guess. npm run dev. One second, what happened? Anything wrong? Da-da-da. So let's start from flight. We are passing undefined because when I'm calling this, I need to pass the flight ID. Okay, good. Send it, and here we go. Successfully coming up, and we are executing this query as well. Right, looks good. So what I'll do, I'll amend my comment. Git commit -- amend, and now I'll do git push. Here we go. Now let's try to create a booking, right? So here we are in the my booking service. Let's go one by one. We have our booking service here, and we must be having our booking repository also, right? Looks good. Inside my booking service, let's take some requirements. First thing, I will need Axios. Sorry. Require Axios. Okay. Apart from that, I will need my repository const require repositories, and from here I'll require my booking repository. Okay, cool. Then I'll write a function const create booking, which will take a data parameter. This should be async create booking, which will take a data parameter. Okay, and here we will try to do a booking, try catch. Okay, try catch. Now, because we have to do a booking, this is going to be one single transaction that we have to do, right? How do we create transactions in Sequelize? There's a very simple syntax. You can just Google the docs. You can do Sequelize.transaction. So I will say const db is equals to require models. And here I will do, and I want to do a managed transaction. I don't want to do rollback and everything myself. If there will be any error, it will automatically roll back the transaction, right? So I'll do a transaction Sequelize.transaction and pass a callback here. Okay, so let's bring it here. Let's bring it here. Let's bring it here. Sorry. Okay, cool. So I'll say const result is equals to db.sequelize.transaction. See, db.sequelize.transaction, and then I can pass a callback async, or I can pass a callback like this, async function. I'll name this function as bookings, booking implementation, booking IMPL, right? And inside this callback, I will pass this transaction object. I'll pass this transaction object. Okay, looks good. Cool. Okay. Now you can see we have a Sequelize.transaction, and inside this transaction we are going to implement most of our logic, right? So what's the logic? What's the main logic that we have to implement? First of all, people will give us a flight detail, right? We need to get the flight from that flight detail. How do we get that? So from Axios, you can make a get request. Axios get request. Very easy to make a get request from Axios. Right, you can just Google for any of the docs. See, you can do something like this. Otherwise, there is dedicated Axios.get method as well. Right. Axios.post method dedicated as well. Let's say Axios.get. So we'll try Axios.get. So const flight is equals to Axios.get. Now, where do we need to make the call? Where should we make the call? Right, where should we make the call? We need to make the call to the address where our flight service is hosted. Currently, it's on localhost 3000. So you might feel like, yeah, localhost 3000 should be a good to go. Technically, yes. But later we don't want raw strings here. So we will transport it somewhere. But for the timing, let's keep it like this. Localhost 3000 / API / v1 / we are going to make a request to /flights / we need to get the flight ID, right? So let's make it a templated string $data.flight ID. Okay, this will give us the flight. For example, let's say console.log flight, and for the timing I'll return true just to see if everything is working fine, right? Create booking. I don't have much logic. I'm just calling the flight. I just want to check whether it is working fine or not. Create booking. I'll return it from, we have already returned it. So we'll go to booking controller. I'll say const require services, and inside services I'll say booking service. Then const create booking is equals, sorry, not const, async create booking, right? And I'll copy the controller code from the other service. Let's call it create booking request comma response, right? And booking service. Now we need to create a new object for the booking service, right? Do we? Oh no, I guess that's a set of functions only, right? So let's just write booking service dot create booking. Okay, and one parameter definitely that we want to pass is request dot body dot flight ID. Okay, this parameter we need to definitely pass for the time being. Okay, let's take a bunch of more things: success response and error response. Okay, we'll get success response, error response, which is present inside our comments, no problem. Okay, and here we go. Looks good, right? Create booking, we will return, and we will go to our routes. Same thing again and again. Let's get booking controller. Here I'll say router dot post. It will be a post request of and one second, we should make a new file, booking.js, right? All the routes should be inside booking.js. Here we should not get booking controller, right? One second. If you remember, here also we used to do the similar things. If we go to routes, we have dedicated routes separate, and then inside this we used to do router.use. So that's what we are going to do. In booking.js, we will say const express is equals to require express, const router is equals to express.router, module.exports router, and here we will say router.post to slash, we are going to return booking controller, controllers, and from the controllers we will get booking controller. As simple as that, right? And in the booking controller we have a function create booking. We are returning the router here. What we will do, we will require it. So const require from booking, I'll say booking routes, and here I will do router.use, if at any point of time you get slash bookings, you use booking routes. That's it. Okay, let's turn up the booking service. Npm run dev. What are we missing? Line number 10. Okay. Express.router. Are we missing something? We return a router. Module.exports router. Oh, sorry, my bad. This should be equals to router. And the service is up. Okay. Now let's try to do this. We'll try to make a post request and let's see whether we are getting a response or not. Localhost 4000 /API /v1 /bookings. And in the body, I'm going to pass a flight ID. Let's say as 2. Let's send the request. It says 404 not found. Let's see why. It should be /bookings. Okay. Okay. Something went wrong. Something went wrong. And it's giving undefined. So let's see why. So here you did Axios.get localhost 3000. Let's make this request directly. First of all, let's see if this address was fine. /2. Okay, this is getting us stuff here. And let's try to also print it. What was the URL that you were sending the request to? Let's put it above. It's inside booking controller. Let's see booking controller. And okay, we need to get the HTTP status codes. Const require HTTP status codes. Right? Let's try again. Line number 19. Error response. Okay, we are not sending anything from there, right? So booking service will say throw error. We'll throw the same error altogether. Okay. Send it. It still says invalid status code. Line number 19. Okay. For the timing, let's just set status codes dot internal server error. Okay. Okay, something went wrong. It's printing undefined. Now let's see the error. Console.log error. What's going on? Are we coming inside booking IMPL console.log? Booking implementation. Send it. Oh, we are not coming inside booking implementation. That's problematic. That means something is not going correctly here. Booking service.create booking is getting called. Request.body is empty. Okay. That's what the undefined is getting printed for. Body. Yeah. Request body is coming as empty. That might be a reason because we have not set up our middlewares here. I'll just quickly get our express.json and URL encoded. Express.json URL encoded. Yep. Send it. Okay. Looks good. Something now is working. Okay. Okay. Promise and all. We are able to make a request. Now this is going for /flight/undefined because I'm sending flight ID like this. It should be flight capital ID. Send it. And let's restart the server. npm run dev. Okay. Now let's see. The request that we were making was correct. Localhost 3000/API/un/flight/2. Okay. Now what is the code? We should do a await here. Right? Let's try again. And this says rollback unsupported protocol localhost. Okay, no problem. What we can do? We can say http:// this. Send it. And you can see we are getting some response. Right. We are getting some response. Status 200, status okay, config, all of this details we are getting, right? And inside the data property, we are able to get the details of the flight. As simple as that. So what we did, we actually wrote this whole address all together here. Right now we don't need this, and we just did an await Axios.get. Okay. Now what I'll do is, I will not put this address here. Instead, I'll put it in my environment variables. I'll say flight service, right? And I'll put this address here. And inside the configs, this one, index.json server config, I will say flight service is process.env.flight service, right? As simple as that. Now we'll go to booking service. Okay, just give me a second. In the booking service, what I'll do is I'll require const require config, and we will get the server config. From the server config, we will say $server config.flight service. Okay. Now we are not going to hard code the address here. We are going to say server config.flight service. If we send it again, you can see we are getting the data. And let's not print flight. Let's print flight.data. Send it again. You can see we are successfully getting a JSON response that we actually set up for our flight service. As simple as that. Now we got the details of the flight. What else do we need for booking? We need, let's go to booking model. We need a user ID as well. Right, we need user ID. Okay. So from my controller, we need to pass a user ID as well. This will be, let's say, request.body.user ID. Okay. Apart from that, we also need, let's remove everything else. Okay, let's remove everything else. Okay, apart from that, we need this number of seats. Rest everything can be computed. Number of seats will be request.body.number of seats. Okay. All of these things will come up inside our service. Now we have the flight details. First of all, we should always check that the number of seats that we want to book, are these even available inside a flight or not, right? So we will say that if data dot number of seats, is greater than flight dot, what's the response that you're getting? You're getting flight dot total seats. Flight dot total seats. What you are gonna do? You're going to throw an error. And because this is a managed transaction, if you will throw an error and if something comes into the cache, if this line reaches an error occurred, the transaction has been already rolled back. Okay. So we'll try to throw an error. We'll say throw, and let's get the details from our old services. Flight service. I'll say this one. Throw new app error, cannot update the data, cannot, or I should say, see required number of seats not available, right? And we will say throw new just we'll throw this an object, and we will say message as number of seats exceeds available seat, right? Number of seats exceed available seats, and I will say reason yeah, we'll just say that. And to be very honest, for the time being, we don't even want to send any specific message here. We'll just say error dot message, right? And let's think about it. So let's not make this much effort. Let's not make this much effort. Whatever is the error we are getting, we'll just throw that error directly from here for the time being. And from here, I will throw an app error, right? That should be better. Copy, paste. I'll say not enough seats available. As simple as that. I don't want to go into too much messaging. I need status code. So const status codes is equals to require HTTP status codes. Okay, and I'll say dot bad request, right? Because we won't be able to fulfill the request, and that's it. We'll throw the error, right? Let's try this. If the server is working, yes. So what is the total number of seats that we have? Let's make a get request. Currently we have 55 seats. Let's say the number of seats we send as 56, one more, right? Number of seats. Okay. If you send it, number of seats we are sending is 56. Okay. Also, one very interesting thing. Can you see this start transaction and commit going on? Right. So transactions are working, but let's see what's happening. Let's print our flight.total seats. Okay. It's not flight.total seats. It's flight.data.total seats. Okay. Let's try again. Once again, console.log flight.data. This is flight.data. Oh, inside flight.data, you have another data object which actually has your total seats. Got it. So let's do one thing. I'll say const flight data is equals to flight.data.data. And I'll say flight data.total seats. Let's send it. And now you can see we are sending an app error. Let's require our app error. We don't have app error here. So let's require our app error like this. Copy. Paste it here. Okay, let's try it again. Not enough seats available. We are printing this. What happened? Do we not have this app error? We have it, right? Da-da-da. Console.log error. 400 app error. We are printing the app error. Looks good. Why it's crashing? In the booking controller, we have a try catch. We are throwing the same error again. One second, let's restart. Once. See, this time the transaction is also rolling back. This is something that we always wanted, that we started a transaction, and if something doesn't work well, we are able to roll back the transaction. This is good. I'm just checking why it's not working as intended. In terms of throwing the error, we are doing console.log error here, and we throw the error here again. What should happen is we should also do an error throw here. Let's see. So the problem here is that this error we are throwing inside a callback. So instead of putting try catch just here, we need to put a try catch here as well, right? So I'll put a try catch inside as well. Cut and paste. Okay. Okay, we'll clean up things. Let's first of all get things working. Let's send it again. Once again. Da-da-da. And now this sequelize.transaction, this is what? This, I believe, should be this is an async function. So we will expect it to work in the form of a promise. We'll return throw new app error, right? We are at booking controller, booking service dot create booking. It's not waiting for it, right? This is because we have async function. Okay, and at last we'll let's say return true. Okay, 1 second. Okay, we are getting data true as well, but these transactions are happening later. Okay, so let's do one thing. Now this is a whole callback based mechanism, and you can see if we are making a call from the controller is not going to wait for it because these callbacks happen later. So let's do one thing. Let's go back. This is our current implementation, right? What I'm going to do is I'm going to return a new promise. Resolve reject, and inside this promise we will do a bunch of stuff. Okay, now we will say here throw new app error. If you throw it here, console.log, and we are going to reject the promise with the corresponding error. We will reject the promise with the corresponding error. Otherwise, we will resolve it for the time being with a true. Okay. And now when create controller will call, everything is binded inside a promise. Till the time this promise doesn't resolve, we won't be returning anything. Let's see now. Everything is working fine. Yes, send it. Okay. Now you can see the controller is not moving ahead, and we are now sticking it here, right? Cool. Now let's see. Also, we don't need to do a try catch here. We can just directly reject it. We can directly reject the promise. So let's clean up a bit more. we can just reject the promise with a new app error altogether. Okay, send it again, and you can see perfectly fine. We are getting not enough seats available, and start transaction. And now you can see it's committing. It's committing. The reason why it is committing is because this is a managed transaction, right? If this is a managed transaction, then we need to manually do a, sorry, we don't need to manually do a rollback and commit. But now you can see we have a structure of the code that we might want to do a rollback or commit manually. Maybe we can move it to a unmanaged transaction and start managing everything ourselves, right? Because you can see that here. This whole transaction should go inside a try catch, right? But I believe things looks good to me, right? We can change it to a managed transaction later, but I believe you can see things are working fine. We are able to initiate a transaction. We just need to make it an unmanaged transaction now, and things start making sense, right? One small bug that we have detected is that we have done a parseint here. If you do a parseint on a true, it will become NaN, and it will also start increasing. So what you can actually do, you can either do a manual number conversion like this. Number of 0 will be 0 and number of true will be 1, or there is a shorthand using the unary operator. So we can use the shorthand dec. And now if we see how many seats we have 65 seats. We want to decrease 10 seats. Now we have decreased the seats. Let's say we want to increase the seats. So dec as 0. So if we will increase the seats by 10, it will come back to 65. Send it. It will come back to 65. Looks good. Okay. So we have fixed a bug. Fixed bug in flight update. So now we already started implementing a bunch of stuff in our create booking service, right? We would like to refactor things a bit because this is our main core logic, right? I don't want it to be implemented in a promise based structure here, right? Because we already have a async function and everything, so it will return a promise. So what I'm going to do is, instead of this, I'm going to make a unmanaged transaction and do most of the stuff there. So I'll put a try catch. Okay. I'll put all of this logic here. For the timing, I'll remove this reject. And here I'll say throw new app error. And for the timing, I'll just say a return true here. Okay. And I want to like make a unmanaged transaction because writing a lot of callback based syntax isn't looking that great. Okay. Cool. For the timing, you can see I'm just making an API call. No as such, I would say DB query we have made, right? So even if we make a corresponding transaction object, currently we have not used it anywhere, right? Also similar to this, we will be making one transaction inside our update remaining seats as well. Why? Because if anyone starts using this, we want it to be clubbed inside one transaction that either everything goes or nothing goes, right? Something like that. So let's start with that. So first of all, I'll make a new transaction object by saying await db.sequelize.transaction, right? This is going to give me a new transaction object. And now wherever I will use this transaction object, wherever I have to like wrap a query inside the same transaction, I can pass that transaction object here. I can do similar stuff inside flight repository, right? I'll make a transaction object there as well. Here you can see we'll wrap all of this inside one transaction. Now you can see that we have a bunch of queries. They're flight.decrement or flight.increment, right? So there is one more argument that you can actually pass, that is transaction as the given transaction, right? So this argument you will pass. So whenever this query is going to be executed, this query will be executed inside one complete transaction, always and always. Okay, cool. So you can see port 3000 is for flight service, port 4000 is for booking service. Okay, let's see what comes up. Right. Also, if we get any error, I will say await t.rollback or transaction.rollback. Sorry, my bad. Otherwise, if everything goes well, I will say await transaction.commit. Okay, but currently this transaction doesn't make a lot of sense here, at least for the time being, because we are not making currently any DB query inside our create booking service, right? So that's for it. So let's see, let's try to make a query. You can see I'm trying to make a booking. Let's see what happens. If I send the request, it says completed the request. Let's see what happened. Inside our flight booking service, we started a transaction and we committed a transaction. Okay. And here you can see what's happening. We are trying to actually do an update, right? So let's see. What did we send? We are just searching for the flight. See, we are just trying to get all the flights, right? So this part is working. Now, what we will do is we will try to also update it later. Once we have made the booking, we will try to also update it later, right? But let's say if the flight data dot total seats is less than the required number of seats. So let's see. If let's say this I send as I require 156 seats, but that is not present, send it. Then you will see that the transaction has rolled back here, right? The transaction is rolling back here. And from here, I will just throw the corresponding error for the time being. Okay. Let's try again. Send it and see something went wrong. Not enough seats available, right? So we are throwing this error and we are rolling back the transaction as well, right? So things look good. Let's try to implement it further. Now what is there? We have the flight data. We have the corresponding flight data. And we have the data about the fact that how much seats the user needs, right? Both of these data we have. That is, what is the number of seats I need? What is the number of seats that is available with the corresponding flight, right? Both of that data we have. Now, how can we initiate a booking? That's our main logic, right? So if the number of seats that we need is greater than the number of seats that are available, we won't be proceeding with the booking. But if that's not the case, then let's compute the total cost of the booking. See, we have a total cost, right? Let's compute the total cost. How will you compute the total cost? Inside your flights, if you see the flight model, inside flight service, you have a price for every seat, right? So what you can actually do here is, we'll say const total billing amount is equals to whatever is the number of seats, multiplied by flight data dot, what's the parameter? Price. Flight data dot price. This is going to be our total billing amount, right? Let's try to console.log this, total billing amount. Okay, and let's send only 5 seats for the time being. Send it. You can see this is the total billing amount coming up, right? So we are able to compute that corresponding total billing amount, right? Okay. Also, this price will be always present because allow null is false, right? So we can be assured about that particular fact. Now, what do we have to do? We have to create a booking. Now we have to create a booking, right? If we go to our booking repository, you can see this is our booking repository, right? Now, I won't be using my CRUD repositories create function. Why? Because I need to pass a transaction. I'll be passing a transaction object, right? And then that same transaction object we need to actually use here. So I'll say async create booking inside this we will be giving some booking data that we have to actually pass, and we will also pass the transaction object that we need in order to bind it in the same transaction. And then you can just use the same piece of code. It's just that instead of saying this dot model, I'll say booking dot create data, and then I can pass transaction as the corresponding transaction, and then I'll share the response. Okay, so let's use it. So in order to create a booking, let's see what all the things we need. We need a flight ID, we have user ID, we have status has a default value, and then number of seats we have been given, right? Flight ID we have, user ID we will pass. For example, let's say user ID we pass as 1. Okay, number of seats we have been given, total cost we have computed, total cost we have already computed. So what I'll do is I'll make a booking payload. Payload is just like a object that you're going to send. This booking payload that we are going to make is going to be equal to, we'll use the spread operator on data, and then I'll say total cost will be a new key that will add, and the value is going to be total billing cost. See, so currently when the user sends something, we have user ID, number of seats, flight, but in order to create a booking we need the total booking as well, total booking amount as well. So I will be destructuring this object using the spread operator and then adding one more key value pair. That will be our main core booking payload, right? That's going to be our main core booking payload. Okay, now we are going to pass this same booking payload in order to create a booking. So I'll say const booking is equals to await this dot booking repository we need to create a new booking repository object as well, just like how we must be doing inside other services. For example, if you see here, we need to create an object like this. So let's create that. Const booking repository is equals to new booking repository, and then I'll say booking repository dot create. I will pass the payload, or booking payload I should say, and I'll also pass the transaction. Okay, I'll also pass the transaction. So this is going to create a new booking for us, and this booking is going to be in what? In a initiated state, right? This booking is going to be in a initiated state, right? And what we are going to do, we are going to reserve 2 seats for this booking. Now of course there will be an added flow here, that first of all you create a booking and you give approximately 10-15 minutes for the end user to actually complete the payment. If they have not completed the payment, then whatever number of seats you have blocked for them, you will release those seats, right? That's going to be something that we have to implement, but of course that particular part of the logic will come up later, right? For the timing, we have a new booking object and we are not integrating any payment service. So we will assume that, let's say with some API call, the person will update the payment status, right? And the status will get updated here. So we can actually implement a bunch of things that can happen once the status actually is in a initiated state. Then we can actually run kind of like a cron, or there are multiple solutions. I'll talk about those, using which you can actually check that within 10 minutes. If the status has not been updated yet, then you are going to cancel the booking or put it in a deemed state, right? All those things we can actually do, right? But for the timing, we have a booking object created that we are going to send the user that, okay, we have created a booking for you. It's valid for approximately, let's say 10 minutes. Please complete your payment, right? We'll talk about that payment flow upcoming ahead as well. And then what's going to happen now, because you have created a booking, now is a good time that you update your seats as well, because this booking has been created. So you should reserve some seats in the actual flight. And how can we do that? Our flight service actually exposes an API of updating the remaining seats. You have to pass the flight ID, you have to just pass the seats, and that's it. And what's the API? this one, right? So let's try to use this. So I'll say const response is equals to await Axios dot patch. We're going to send a patch request, and if you want to see how to send a patch request, let's see. Let me open Google in front of you. Right, you don't need to always remember it. You can just quickly Google it. Axios patch request. Right, and you can see inside this patch request, you're going to send the ID, but rest of the details are going to come up. That is, how many seats you have to reserve is going to come up in the body, right? So let's see how can we send the body. So see, you can actually send it like this. Axios.patch, you can send the URL and then send the corresponding arguments, right? Let's see that here as well. See, then you can send the corresponding arguments. Pretty simple. So let me show you. So I'll say dollar server config dot flight service slash API slash v1 slash flights. Now here I will put the flight ID. What is the flight ID? You can say data dot flight ID. Okay, data dot flight ID, and then you're going to pass an object. You're going to pass an object. Inside this object, what do you expect? You expect a seats parameter. You expect a seats parameter, and this seats parameter is going to be equal to number of seats that is expected here. Right? If anything goes sideways in this Axios call, that means if this API call doesn't work, we are going to roll back the transaction. But if this API call works, that means you have successfully decreased the corresponding number of seats, right? And then for the time being, I'll say return true. I'll just say return true, right? Or we can return the booking object. Let's say we can return the booking object. That's it. And we are not using this response anyhow. So I'll just remove it and just keep the await Axios call. Okay. So see what we have done. We first of all check the number of seats are available or not. If they are available, we compute the billing amount. We create a temporary booking with the status as initiated, right? Then we are going to create an Axios request so that at least 2 seats we block for the user. Corresponding to that, here also we are going to use a transaction, right? And we have also kept a row lock, right, on the corresponding flight, right, till the time you are decreasing the number of seats. And then if the seat decrease also works, then we are going to commit the transaction. Once you commit the transaction, then you return booking. Everything is a good to go. If anything fails above, we are going to roll back the transaction. As simple as that. Okay, let's try. So for the time being, let's see how many seats we have in the flight ID 2. We have 65 seats. Okay, let's try to create a booking for 5 seats for flight ID 2 with user 1. Let's see what happens. Send it. It looks like it initiated the booking correctly. Let's see if 5 seats are gone from here. You can see the number of seats are now 60. 5 seats are gone. And here you can see when we were creating a booking, then also we were using a transaction, and here as well you can see we are using a transaction. The only problem here that I can see is that I'm not committing the transaction anywhere. So I should actually do await transaction.commit. Okay, and let's wrap all of this in a try catch, because if anything goes sideways, you have to roll back the transaction. Right, if anything goes sideways, I will just throw the error, but before throwing the error, I will say dot rollback, and it's a function. Both rollback and commits are function. Okay, okay, Let's try again. So now currently we have 60 seats, right? Let's create another booking. Let's create another booking for the user. Send it. We have created another booking. And now technically we have 55 seats left. And you can see properly we are committing the corresponding, I should say, transaction as well, right? And here as well, proper commit and everything is happening. Let's say our flight search service is down, right? For some reason, our server has crashed or something, and you try to initiate a booking. Okay, so let's me crash the server. So you can see flight service is now down. If now you will try to make a corresponding booking, send it. We are also failing. Oh, sorry, my bad. This one is for booking, right? Let's send it. And you can see something went wrong. We are getting a detailed error and everything here. And why is that? Because it's an internal server error, right? Because the service is down, right? So you can see nothing is happening which is not expected. You started a transaction and then you rolled back a transaction. As simple as that. So I'll commit all of this. Added booking logic with transactions, right? So you can see pretty robust and efficient implementation we have written, keeping all of the corner cases in mind. A few of the students might be having doubt that what is the current implementation of booking actually representing. It's going to represent something like this, that let's say you selected, let's say you want to go from Bombay to Hyderabad 2nd of August, 2 travelers, you search for it. Okay, so searching is going on. Cool. You selected a flight, right? And we have created a booking for you, right? We have created a booking for you. If you will complete the payment from here, this booking is gonna work. I can actually leave this page in front of you after 10 odd minutes. I guess 5 or 10 minutes timer they have. This page will automatically refresh saying that you are not doing anything. We are reverting it. This is the current state, right? Now, once you click on continue, let me just continue on a different screen so that you don't see any details or something. Okay, I'll just fill in some random details. Okay. Okay. So you can see I have filled in a random details. You can see the itinerary was created. Same step we are at. Now we click on continue, right? Okay, we click on continue. You can see now we are going to initiate a payment, right? Technically, now we are going to initiate a payment. If this payment is not going to work, the booking that we just created, it's going to blow up, right? That means, let's say after 20 minutes, they have given a 20-minute timer. After 20 minutes, if the payment goes through, they can check that what is the current timestamp and what is the timestamp of the creation of the booking. If the difference is more than 20 minutes, this payment is not eligible, right? You might be thinking that, okay, what if the person never creates a payment? Then we will be having a booking created in our DB forever, right? No, there is a resolution for that. We will talk about it. But I believe now you understood what exactly I meant when I said creation of a booking. Now what we have to do is, technically what we should do is we should create a different payment service altogether that should handle all of your payments. Or let's say there will be a third party payment gateway or payment service that you are going to integrate. We don't have to go into that much amount of complexity. What I will do is I'll just make a simple API inside our service. Okay, I'll say async, let me close it, function make payment. Okay, I'll say async function make payment. It is just going to get a data. Data will be about what is the booking ID and what is the amount and what is the user ID. If the user ID matches the user ID for which the booking has been created and the amount matches the booking amount, we will update the status of the booking. Okay, so I'll put a try catch here. One second. Yeah, cool. So now what we will say is that we'll first of all try to get booking details. So I'll say const booking details is equals to await booking repository dot get, and I'll send data dot booking ID. Right. I'll send a booking ID and try to get the booking details. Okay. Now inside these booking details, if booking details dot, now you have a property total cost. If booking details dot total cost is not equal to data dot total cost, that means the payment that you want to make, that's not equal to the payment that is expected in the booking. What we are going to do, we are not going to we will not let it go through. Also we need to bind this in one transaction. So I'll say const transaction is equals to and technically, yeah, const transaction is equals to, what's the function, await db.sequelize.transaction. Right. Also this get function that we have, I will override it. This get function that we have, we will override it. Because we need to bind it in a transaction. So I'll just override this. Just like this transaction. Okay, cool. And let's pass the transaction here. We will get a transaction object as well. Okay, cool. Now if this is not the case, what we are going to do, we are going to throw a new app error saying that the price or the amount of the payment doesn't match, right? And again, I'm mentioning that we are just mimicking the whole purpose of a payment gateway through one API, because we are not integrating a payment gateway altogether. Now you can see if the cost doesn't match, then we are going to throw an error. Otherwise, if let's say booking details dot, we have a user ID is not equal to data dot user ID, then also we will throw an app error. The user corresponding to the booking doesn't match. If everything is good, if the user also match, then what we are going to do, we are just going to simply create a corresponding booking, right? And how do we do that? Let's say we will say, we assume here that payment is successful, right? And now we have to just update the status of the booking from pending to what? From pending to booked. Okay. So what we are going to do, we'll go to booking repository, and again we are going to override a CRUD function for update. I'll pass a transaction here, and we need to pass a transaction here. Okay, as simple as that. And then what we are going to do, we will say const response is equals to await booking repository dot update. We are going to update the booking. What are the parameters required? It requires the booking ID. So I will say data dot booking ID, and we will say the status of the booking, we need to convert it to booked. Okay. So how do we get the status? We have a common enums, right? We have a common set of enums. I'll require them. We'll get enums, and then we destructure the enums, and here we just need for the time being booked. I'll get the booked enum. and I will say status is booked. And then we are going to pass the corresponding transaction. That's it. If everything goes through, we will say await transaction dot commit. If something goes wrong, we will roll back. If something goes wrong, we will roll back. That's it. I'll export make payment. Here as well, I'll just copy the whole code of create booking because not much logic there is in controller. I'll say make payment. I'll require, I'll say, we don't need to do this. We don't need to do this. Let's remove these logs. Okay. We'll say booking service dot make payment, right? And in the data object, what do we need? We need to pass the user ID. Then we need to pass the price, right? We need to pass the total cost, booking total cost we have to give. So request.body.total cost, user ID, and we'll also pass the booking ID. Right, we'll also pass the booking ID. That's it. Then we will return this make payment, right? And now we will go to booking.js. Let's initiate one more router.post, and I'll just say it as /payment. And corresponding to this, we need to have a booking controller dot make payment, right? We have also not initiated any middlewares for the time being. We can technically add those, but I'm halting them for now because that's going to be your takeaway task, right? Adding middlewares to post and payment and the create booking. Save it. Let's try to make a payment. Post request. Let's get a booking ID. So we must be having some bookings. Let's go to MySQL. Use flights, right? And then we will say select star from bookings. We have a booking. Let's say we'll take the booking ID 2, right? In the body, I'll give the booking ID as 2. User ID I'll give as 1. User ID as 1. And the total cost is 17,500. Total cost is 17,500. This is cost. Let's send it to /bookings/payments. Once again, something went wrong. Oh, sorry. Let's turn up the server for both of them. Okay, it says 404 not found. It's payments. It should be payments. Send it. It says successfully completed the request. Let's do select star again. And you can see the status has been changed to booked, right? So we are able to successfully change the corresponding status. Now, all we have to do is we have to first of all put a check here that the timestamp at which we are creating the booking and the timestamp at which this booking is getting created. For example, the timestamp that we are updating the booking is, let's say, 5:20, and this booking was created at 4:50. Then 20 minutes have gone, right? So post 20 minutes are gone. This should technically never go through. We should add that particular logic as well. Now, in order to implement that, we have a corresponding library, datetime helper. This actually compares time for us, right? This datetime helper actually correspondingly compares time, right? So let's try to see what all options do we have. So let's say if somebody tries to create a payment, right? in the booking details, let's not do update here for the timing. I'm commenting the update. Let's print the booking details, console.log booking details. Okay. Let's try to get for booking number 1, send it. Let's see what do we get. See, these are the details that we are getting. In this booking details, you have a created at, right? So if let's say I create a new date time object, new date object with booking details dot created at, and then let's say print it console.log dt. Let's see what do we get. See, we are getting the exact datetime object, right? Now let's pick this datetime object and let's open JavaScript console and let's see how can we do the comparison. Okay, so I'll say dt is equals to new date object. Right? Sorry, capital D it should be. And now what we can actually do is we can actually also do new date. If you just do new date without any parameters, it will give you current time. This is the current time, and this is the time 8:27. This is the current time 8:56, right? So if you do t is equals to new date, this is going to give you current time. Okay, t is equals to new date is the current time. What if I do t minus dt? Let's see something happens or not. You can see they are giving us some milliseconds. If I convert millisecond to minutes, or let's say seconds, this is 1710 seconds. If I convert it to minutes, it is 28 minutes, right? So technically, using the number of milliseconds, we can actually do the comparison. For example, if let's say I want to keep a tap of 5 minutes, that within 5 minutes, if the person does the booking, that's it. So how many milliseconds are there in 5 minutes? In 5 minutes, there are these many milliseconds. So you can just compare. If the number of milliseconds that you are getting by this difference is greater than this number, then you will not let the booking go through. Okay. So what we will do is, I'll say booking time is equals to new date, and then I'll say const current time is equals to new date, and we will say that if current time minus booking time is greater than this particular number, then also we will not let the booking go through. We will say booking expired. The booking has expired. Okay, the booking has expired. And also, what one thing we can do is we can actually check in the database if the status of the booking is not already expired, right? You can see we have some booking status, right? Booking cancelled, initiated, pending. If it is not already cancelled, right, you can even put a check here that if booking details dot status is cancelled, then also you will throw the same error that it has expired, right? Let's get cancelled, right? And let's say if it was not already cancelled and you tried to make a payment and then you realize that okay, the time has gone up, then technically here you can actually update and make it cancelled now, just to keep our sanity check there, right? We can manually do the cancellation here that you will cancel the booking, cancel, right? Otherwise, I'll tell you the mechanism using which we will manually put it cancelled, right? But for the timing, you can actually see that here, right? That we are going to make it cancelled, right? Let's save it. If everything goes well, then we are going to complete the booking as status booked. Okay, let's try to make the payment now. For booking ID 1, you can see the payment is in initiated state. If I will try to make the payment, this should go to the cancel state because we are beyond 5 minutes. If I send it, the booking has expired. and you are cancelled, right? That's good. And let's say if I create a new booking, I created a new booking. This time the booking ID is 3. The booking ID is 3. And 5 minutes are not yet gone. See, booking is in initiated state. If now I will try to send the same payment, booking completed, and you are booked, right? You are actually booked. So this looks good, right? We don't need the response. We don't have any use case of the response here, right? And let's see. All of this looks good. I'll just commit all of this. Added booking payment logic. Git push. Here as well, I'll see if there is anything to be changed. Git status, git add, git commit, added transaction to update seats. Git push, right? Both of them are technically pushed now. Now, one thing that we have to do is that every 5 minutes, what we should do is we should check, or we can do every 5 minutes, every 2 minutes, every 1 minute. We have to do one thing. If there is any booking whose creation time is now beyond 5 minutes, I should manually update the status to what? Cancelled, because this booking is now no more available for the person, right? This is something that we have to do. Apart from that, one more thing. When you actually cancel the booking, see, this is where I'm manually canceling the booking. When you are actually canceling the booking, you have to do one more thing. You should bring back the same number of seats that you actually reserved for the booking, right? That is something that we have to actually do, right? So what we can actually do is we can write a function cancel booking. During the cancellation of booking, we will pass the booking ID, right, that we have to actually cancel. And now I'll say const transaction is equals to await db.sequelize.transaction. I'll say try catch, right? First of all, I'll get the booking details, right? So, or I already have the booking details, or maybe we can get it, no problem. So let's get the booking details like this, right? We'll get the booking details, right? If booking is already cancelled, if booking details dot status is already cancelled, then what we are going to say? We are going to say return true. That's it. It's already cancelled. We don't need to bang our head anywhere. And I'll say transaction.commit. If it is not already cancelled, then before you actually cancel it, you need to make an API call to update the bookings. And how do we make the API calls? We already have an Axios call where we are increasing the number of bookings, right? Increasing the number of seats. So here I will say booking details dot total seats. And if you want to actually make it what? An increasing call where we will increase the number of seats, I should pass a parameter decreasing as 0, false, right? You can also manually call it false because there is type coercion that we have already applied, but let's keep it 0 for the timing because we already are aware about that. Once this call goes through, then actually you should do this cancelled. Then actually you should do this cancelled. And once cancellation is done, then you will commit the transaction. If something goes wrong, we are going to roll back the transaction. As simple as that, right? So now let's cancel booking from here. Await cancel booking. I'll just pass the booking ID. Okay. I'll just pass the booking ID. That's it. Here we go. So now let's create a booking, right? And let's go here. Let's create another booking. Sorry, servers are down. Sorry, my bad. Okay, we have initiated a booking. Now what I'll do is I'll manually update the time. Right, if you do select start from bookings, so I'll say update bookings set created at is equals to, I'll set the created at as a very old time, this where ID is equals to 4. See, now you can see the created at has been changed to 14:57:49, right? This looks good. And one thing that is strange here is, I guess my MySQL is not taking the correct time, is it? This looks like 2 p.m. My MySQL is not taking correct time. It will always fail, will it? But it was not failing, right? Maybe some system time issue I might be having, right? And if I add 5.5 hours, what happens? 5 is 19. Oh, it's good. So we are in plus 5:30 time zone, right? So it's okay, right? No problem. This is good. Time is this is the correct time. Now you can see I have expired this booking. Now let's try to make a payment for this booking. For booking ID 4, send it. It says something went wrong. Okay, it doesn't complete. Let's see what happened. So it decreased the total number of seats, right? It should not have decreased the total number of seats. Let's see what happened. So I have printed booking detail. Let's try again once again. Booking ID is correct. Yes, booking ID is 4. User ID is 1. User ID is 1. Payment is same 17,500. Let's send it. It says something went wrong. Let's see what happened. So it started a transaction. Then you can see we did select star. We are getting a booking object. Inside this booking object, status is initiated. What we are checking here, we are checking the status is equals to cancelled. If it is already cancelled, we commit. Otherwise, we make an API call. If we are making an API call, that means here you can see another update actually came up. Did it? No update is coming up, right? No update is coming up. One second. Let's send run npm run dev. Send it. Okay, update is not coming up here. Why? Because we are not sending the correct flight ID. Maybe first problem is this. Booking details flight ID should be there. And this is also problematic because we are directly setting the booking ID, right? We don't have data.booking ID. So that's the problematic thing. Let's try again. Send it. Okay. It failed. Why did it fail? Let's see. It's failing with 400. some other mistake we might have done. Let's print the booking details, console.log booking details. Let's see if we are able to get the correct booking or not. Send it. Still in initiated state, no problem. Okay, this is the booking. We have booking.flight ID, booking details.flight ID, right? Booking details.totals. Oh, sorry, this is number of seats. My bad. This is number of seats. Okay, let's try again. Still something went wrong. Let's see now what happened. Okay, so you can see that this time the correct API call went through. It increased the total number of seats. It is increasing the total number of seats, but something is not going wrong correctly here, because again data.booking ID. See, same mistake. We should do booking ID here, right? That's why it's happening. Let's try again. I guess now it should work. It's still in initiated state. Send it. The booking has expired, and this is in a cancel state, right? Okay, and you can see the cancel booking transaction. This transaction actually committed itself, but this transaction actually rolled back. You can see one commit, one rollback. Things going pretty good, right? So this logic we have actually implemented. Added cancel booking logic. There we go. Now what we have to do, we need to execute the same service function. We should actually execute the same service function every I would say, or similar logic I should say, every 5 minutes or 10 minutes, to see what are all the bookings that are now in a deemed state that are never gonna go through. We should clean up that from our database. Let's see how can we actually do that. Now you can say that after every some interval we have to execute a task, right? If we have to execute a task after every time interval, then how can you do? You might think that, okay, we should set a timer, that let's put a set interval that after every 5 minutes do something. There is a problem to that. If the server is down for some time, then those transactions are not going to work, right? Then in order to actually handle this kind of case, we have something called as cron jobs. Let me show you what is cron jobs. Right. So every day at 10 a.m. in the morning, you see that you have a brand new email coming up on your email ID from some brand about some marketing technique, right? How every day at 10 a.m. in the morning, you get this similar email from the same company? Is somewhere someone sitting and actually sending a bunch of emails at 10 a.m. in the morning? Of course not. So what you can do, you can actually schedule a task, a recurring task you can actually schedule using something called as a cron, right? So if you see what is a cron job, cron is a work schedule hypervisor that runs assignments at prescribed times. So you can actually prescribe a bunch of timings on which a cron should run. For example, you can actually say that every day at 10 a.m. in the morning, execute a particular thing. Or let's say every 5 minutes from now, do something. Or every Tuesday, Thursday, Saturday at 10 a.m. do something. You can customize it anyhow. You can see there is a similar kind of a script you will see people writing for cron jobs, right? And there is a cron tab file. In Linux machines, there is a cron tab file, right? You can actually see that cron tab file. I believe I can also open it considering that I am on Mac, right? So to display the contents of the cron tab, you can do cron tab -L. It says no cron tab for Sanket Singh. So currently there is no cron tabs actually configured, but you can actually set up a cron tab. If I do cron tab -E, then you can see it is asking me to set up a cron tab, right? I will not manually set up a cron tab because you can see setting up a cron tab is not a very verbose syntax. Why? You have to actually write things in the form of a star. For example, let's say if you say star by 5, star, 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 this is going to run a particular cron job every 5th minute from now. Every 5th minute from now. This is going to run it every quarter hour, at every 30 minutes, and so on. Right? You can configure it anyhow. You can actually read about it. But we are not going to go the hard way. There is a package called as Node-cron that simplifies our life at a very big level. You can just install it, and if you want, you can give cron schedules like this, or you can actually write things like these: Jan, September, Sunday. You can also write that there as well in a normal cron file. But here the best part is that you don't have to actually edit your cron tab file. In your same project, what you can actually do, you can just write a, I would say, cron file, a normal, which is going to be normal JavaScript file. You can require Node-cron, and then you can schedule a particular task to get executed every time. Okay, so let's see this in action. I'll install Node-cron. Okay, now what I'm going to do, I'll go to helpers, and I would say, yeah, let's go to commons. I'll create a new file, cronjobs.js. Okay, and now I'll say const cron is equals to require Node-cron. Once you're done with this, then you can actually just write a schedule like this. Okay, you can write a schedule like this. Got it? And what we will do is, I'll write a function schedule crons. Inside this function, I will pass all the crons that I have to schedule, and I'll say module.exports schedule crons. Okay, and then inside my server file, that is the main root server, I'll require it here. Const, first of all, let's return it. I would say crons as require cron jobs, and here I'll say require /util/common, and from common I'll get crons. And what I'll do, once I run the server successfully, I will also run the crons. Okay, so currently the cron that we have configured is going to run a task every minute. I want to do it, let's say I want to run it every 2 seconds. How can you do that? You can just directly Google it. How to write a cron to run a script every 2 seconds. Right? So you can see there is an example for every 5 seconds. See, this is for 5 minutes. Let's see for 5 seconds. How can we do that? Or we can also ask ChatGPT, to be very honest, but we'll definitely get some answers here. So this is going to run it every 10 seconds. I'll copy paste it here. And let's say instead of 10 seconds, I'll say 5 seconds. Every 5 seconds, I'm going to do a console.log. Okay, cool. Let's run our server and wait for 5 seconds. I guess we can wait for 5 seconds, not much time. Okay, it says crons is not a function. Let's see why. Because I by mistake called schedule crons here. Let's run it again. Okay, server started successfully. See, after 5 seconds, it's running a task. It's consoling it, right? See, if you will try to see, is there anything in your cron? If you won't see that, because how Node-cron actually handles it, we don't know how exactly it actually brings the task to the crons, but you can see everything starts working, right? So now inside this, what we can do is, let's schedule it for every 10 minutes. Okay, every 10 minutes. This is something that you can do. Every 10 minutes, what should happen is,
we should run a script from our booking service that actually checks all the, I would say, bookings that are older than current timestamp and make all of them cancelled. Okay. So let's see how can we actually do that. Let's see how can we actually do that. For the timing, I'm commenting this out. I'll write a function async function cancel old bookings. We don't need to expose it like an API, right? What I'll say is try catch. Inside catch, I'll say console.log error. Inside catch, what we will say is const current time is equals to new date, right? And let's try to write a SQLized query that is const response is equals to await booking repository dot. Now inside booking repository, we should technically write a function. Let's go to booking repository. Where what will I do is I'll say async cancel old bookings, right? It will get a timestamp, and here what we can say is const response is equals to await this dot, and we should not say this dot model, we can just directly say booking. Everywhere we can just directly say booking because this dot model is also pointing to booking. We'll say booking dot update, right? Or let's first of all do booking dot find, right? Booking dot find, let's do booking dot find, and now we want to find all the bookings which are, if we compare them with respect to timestamp, are less than 5 are older than 5 minutes. Okay, so let's see. If I do new date, if I do a new date here, you can see this is the date time object that we are getting. Let's Google how to get date time object in JavaScript for 5-minute old timestamp. 5-minute old time. You can see we can just directly subtract a bit, or let's see. It just takes, so if you want to get a minute ago, you can see this logic we can actually execute. So you can see this is a minute ago. If this is a minute ago, instead of multiplying it with 60, what is 5 minutes? 300, right? You can see this is 5 minutes ago. So what we can actually do is we can actually create a new datetime object, which is 5 minutes ago here. Time 5 minutes ago, right? And then we are going to pass that same timestamp saying a where query, right? So let's see. SQLize where on timestamp. Let's see, can we do where query on timestamp? This is just for defining. I believe we can do. Let's just see SQLize where. Okay. I believe there must be some examples, not sure, but let's see where. So you can see you can pass the parameter and you can actually use some operators. Let's go to the operators and we can say greater than. I believe it should work. Let's try. So we will say where, what's the property? Created at
created at is, let's get the OP object from SQLize. This is OP dot greater than, see, OP dot greater than we can do, and then we can pass a value. Let's say timestamp. Okay, let's say timestamp. Okay, cool. And I'll say return response. For the timing, I'm returning a response. I'm not updating currently anything, but let's see whether we are able to get all the old bookings or not. So I will say booking repository dot cancel old bookings, and I'll pass my current time, or I would say just a time object. Time. Okay, so let's see whether we are even able to fetch all the bookings which are older than 5 minutes or not. Okay, and we will say return response. What we will do is, in our cron jobs, we will say const booking repository is equals to require, sorry, not booking repository, we need to get booking service. Booking service, let's get it. And we will say that let's execute it for every second. Let's execute every seconds, right? So what we are doing, this cancel old booking, I'll export. This is date dot now. This is my current timestamp minus 5 minutes will give me the new date object. I'm passing that and trying to get all the corresponding bookings. I'll say await booking service dot cancel old bookings, and whatever is the response, let's make it an async function. Console.log response. Okay, so let's go to our index.js file. Okay, crons are up. Let's wait. Something not working, accessing non-existent property. Let's see what's happening. Booking service dot cancel old bookings, cancel old bookings, and this is taking booking repository, cancel booking. Okay, I guess there is some wrong function that I'm calling from here. Cancel old bookings. Okay. Let's Google it. Why it's showing something like this? Something wrong we are calling, I guess. Okay, got it. So what's happening is, if we call the booking repository, here we are calling the booking service, right? Inside the booking service, we are calling the booking repository, new booking repository, and we are calling booking service dot old bookings, where we are saying booking repository. Oh, my bad. See, we have a booking repository object, right? So I was using the wrong object here. I'm using the class. That's wrong. Now let's see. We have updated it. Let's restart the server. Let's restart the server. Let's see whether it goes every 5 seconds or not. I guess it's 10 seconds now. What's the cron config? It's 10 seconds now. It's still showing us the same error. Let's see. First of all, let's not directly require the booking service from here. We will say booking service and then we say booking service dot cancel old bookings. Let's try now. And you can see the error is gone. The error is gone, right? But we are not printing anything. We are not printing anything. Let's see. Console.log. Starting cron again. Let's see. See, starting cron again is coming up. So what's happening? Await booking service. Cancel old bookings. Response. All of this is coming up. And let's do a console.log here as well. Console.log inside service. Let's see if we are calling the service properly or not. Okay, it's still not calling the service properly. Let's see. Let's see what's inside booking service. Let's see what's inside booking service. See, booking service is still coming as undefined. That's why it's not calling anything. And why that might be going on? We have booking service returning. Inside the booking service, we are exporting an object, create booking, make payment, cancel old bookings, right? Let's see what we are requiring from the whole service object. Let's see service. Let's see complete service, what we are actually getting. Let's comment this out. Let's comment this out. Somewhere in the import, we are getting a wrong answer. Let's require it again. So we are one folder out. We go to services. We go to index. I believe what's going on is if we go to index.js, let's do one thing. Let's remove cron from here. We do require cron job, module.export, schedule crons. Let's do one thing. Let's remove cron from here for a moment. And then instead of getting it from utils common just directly, I'll say slash common. Let's say cron as slash common slash cron jobs. And we'll say cron as a function we will execute. Let's see what happens. And now we are getting the service. So the problem that was existing was somewhere here also, like we can take a look at what was the cleanup required, but somewhere what was happening when we were exporting these crons from here, right? Internally, what was happening? A circular dependency like this was happening. That is something like this, that you try to inside file a.js, you try to require file b, and inside file b.js, you try to require file a, right? As simple as that. So we will see, we can actually detect where that was coming up, but you can see now our cron is working. Let's first of all get the cron working up and running, and then now let's try to get some response. Let's see whether we are getting the booking service response or not. So we started the cron. Okay, let's see booking service dot cancel old bookings. Let's see whether we are going inside it or not. Also, we have booking service dot cancel old bookings. Sorry, this is a service object, my bad. This is service, and let's see. We can actually say booking service. Let's print booking service here and booking service dot cancel all the bookings. Okay, booking dot find is not a function. Okay, so now at least we are able to actually reach somewhere here. Why find is not a function? Let's see. I guess this is find all. This is find all. Okay, so you can see we are trying to create a booking. Sorry, we are trying to select a booking. And we are currently executing a query like this, right? And you can see this query is not exactly working. If you try to execute the same query in MySQL, you can see nothing is coming up. Why? Because this created at is actually a date time and you are comparing it with a string, right? This direct comparison will not work. We need to find a workaround, but at least our crons are exactly executing after every 5 seconds and we are able to fetch the details of the bookings. So now Sequelize is going to compare everything. Here we should do less than, that is all the timestamps, all the bookings which were done before the current timestamp. I want to get all of those, right? Now let's see. And here you go. You are getting all the corresponding bookings, right? And now instead of finding all the bookings, let's do an update. I guess there is update all also, or I just update. Let's see. Let's just quickly go through Sequelize update API, Sequelize update. Let's see, do we have any update all or just update works? Updating instance. Sequelize update multiple rows. I guess it should update. It should update. So I'll say Sequelize.update, right? Then we are passing the query to find, right? Let's see. First of all, we have to pass the field that we have to update, and then we can pass the where query. So now let's pass the field to update. I will say status cancelled, right? I'll set the status as cancelled. And we need to get this cancelled from our enums. These are the cancelable enums, right? So you can see we got the enums. From the enums, we are getting the cancelled enum. That is something that we need. Okay, let's see. Server come up. And technically it says it has updated all the set of bookings, right? So select start from bookings. You can see everything is now in a cancelled state. Now the problem is, if something was booked, that is also getting cancelled. I don't want to do that, right? If something was booked, that also is now going in a cancelled state. So what we should do is, we should say where, and we need to put an operator op.and, right? And this takes an array, I guess. op.and takes an array. Does it? See, op.and takes an array. Inside this array, first of all, I will pass an object where created at property is there. Then I'll pass an object that status of the booking is op.not. See, there is a not equals to booked. Okay, let's get the booked enum. So I just want to cancel only those which are not booked, right? Okay, so let's do one thing. Let's update bookings, set status is equals to booked, where id is equals to 1 or id equals to 2. Okay, so I'll set 2 of them as booked, right? And let's stop the server for the time being. So now if you do select start from bookings, you can see 2 of them are booked. And now I will say id equals to 3 and id equals to 4. I'm going to set as pending. See, now 2 are pending, 2 are booked. So we are not going to touch which are the booked ones, right? Let's start our server. So every 5 seconds, it should query and make an update. You can see only 2 records are updated. You can see the pending ones are now cancelled. Booked are not touched. And the next time this query occurs, right, nothing changes as such. And what we will like to do is, we should not execute it every 5 minutes. Technically, we can execute it every 30 minutes, something like that. Every 30 minutes we can execute, right? And that's it, right? So we have successfully registered a cron. And what this cron actually does is, we don't need any console.logs. What this cron actually does is, any bookings that are now in a pending state since last 30 minutes and nobody has changed anything corresponding to that, it's going to vanish it out. You can make this update every 20 minutes, every 10 minutes. But again, just think about one simple thing. You have to make a query on your database, right? Definitely you don't want to do that every second, because that's going to load up the database. Every 5 minutes, 10 minutes should be something that you can definitely live with, right? And what I have done is, any status which is not booked is now not required for us, right? So if it is initiated or if it is pending, in both of the cases it should get cancelled. If it is already cancelled, then we should not update it, right? So let's add that logic as well, right? That is, this status should not be equal to, let's see, booked, and we can do something like, let's see, now we have to do a check on not equals to for booked, and another check on status op dot not equals to on cancelled, right? So if something is not booked and not cancelled, all of those should get updated. Let's see. If now I execute it like every 2 seconds, for example, I've changed the cron. You can see no record is going to get updated, right? No record is going to get updated. As simple as that, because there is nothing in the non-booked or not non-cancelled state, right? Let's bring it back to 30 minutes. That's it. So now you know how to schedule jobs, right? Now you know how to schedule jobs. So using this, you can actually schedule mails. You can do a bunch of stuff, right? Added cancel booking logic with cron. Hit push. So we are going to remove all of them which are now in a dim state. Ideally, if let's say you are going to allow someone to have a booking time for 20 minutes, checking your cron every 10 minutes should be a good way to go for, because inside our booking logic as well, we have kept a particular check about the time. So here also we are robustly checking it. So no worries on that part. And I believe our booking service is definitely in a very good shape. Now we talked about 3 major problems. One of the problem was concurrency, that if let's say 2 persons are trying to create a booking and we have only 1 seat left and both of them makes an API call, who will go through? We have handled that using locks and transactions. One more major issue was, what if from the client tries to actually make a payment. There was some processing going on. The payment went through, but while returning the response, something went wrong, right? Now you might feel that, okay, one layer of protection we already have for this problem by setting up a TCP connection. By setting up a TCP connection, we already have a one setup of layer that if payment goes through, we will definitely return a response. Why? Because TCP is a reliable connection. On TCP, there won't be a case that response never goes back, right? But there is a different case for us. Sometimes what happens is the payment gateway takes your OTP, takes your payment mechanism, and then for the time being, return you a response that your response is under processing. Your response is under processing, something like that. And then later, let's say, what they do is they try to send a notification or something that, okay, your payment has been now successful. Now the problem here is, in that other event that they are sending, if let's say they have a mechanism like this, you initiate a payment, they return that, okay, we are processing your payment. And let's say your payment has been already processed, but that notification you never receive. This can be a valid concern, right? In these kind of cases, what happens is people end up doing double transactions, right? People end up doing double transaction for the same booking. Although for that booking, the transaction is already done. You just have not yet received the notification. But what happens is you end up losing your money twice. And this can actually happen in multiple cases. For example, in any case where some amount deduction or some amount increment is going to happen. And let's say if a person retries 2 times. For example, let's say there can be a situation like this, that due to some client side mistake or somehow, let's say the user initiates 2 payment requests by mistake. I'm not saying manually, by mistake, the user initiates 2 payment requests for the same booking. One payment request has already gone through. Like, of course, now these 2 are going on. They're not going to go in a transaction because both of them are going into transaction and we have set up isolation and everything. That's why not both of them will go at one point of time, but one after another, they can definitely go, right? One after another, they can definitely go. How can you handle this? So these are some of the retry situations that actually occurs in the systems. And there is a concept called as idempotency. There is a concept called as idempotency. What is idempotency? It is a property of certain operations in maths and computer science where they can be applied multiple times. Without changing the result beyond first application, right? That is, let's say you made a payment request and the payment is done, but by mistake one more request came up. Now, because this was the first request, this is the second request. Only the first request will be applied. The second request will not show any effect. In case first request was not successful, then this is not the first successful request. Then we will definitely try to apply the second request. So what idempotency means that after your first successful application, if you repeat the process, it's not gonna work. And then from here only we have a concept of idempotent APIs. Idempotent APIs. What are idempotent APIs? Idempotent APIs are those kind of APIs in which, if let's say the action of API has been already successfully implemented once, and by mistake, due to some system error, front-end mistake, some user mistake, one more similar request comes up, we are not going to apply the second one, third one, and beyond that. After first successful application, it's not going to work. That means if we are able to make our payment API idempotent, even if somebody makes 2 requests, the payment is only going to go through once. As simple as that. And that's what we have to implement. We will try to make our make payment pseudo dummy, whatever API you want to say that we did for payments, an idempotent API, so that this kind of an issue doesn't occur for our user. Now, how do we actually manage this? In order to make an API idempotent, all you have to do is you have to send an idempotency key. This will be the duty from your request mechanism, that is whatever is your initiation mechanism, that is, let's say your mobile app or let's say web app, from wherever you are actually going to allow the user to actually make an API. From there, we are going to send an idempotent key. This idempotent key will be sent to the corresponding service. If I would say, let's say in case of our payment, if the payment actually went through I'm going to save this idempotency key inside my server. Somewhere I will save this idempotency key, right? I'm going to save this idempotency key. And before we actually use this idempotency key, I will check whether this idempotency key was already saved or not. If it is not saved, then what we will do, we will continue with our operation. And once the operation is successfully committed or completed, then we save our idempotency key. Now, once we have saved it, if you try to retry with the same idempotency key, we are not going to allow it to go through, right? That's what we are going to do. These idempotent APIs are solely made to avoid these retry mistakes, right? Because now you might be thinking, sir, what if the user somehow manually changes the idempotency key? Yes, let's say the user somehow manually changes the idempotency key. That's the point when we are not going to handle their retry. They are manually trying to do a retry. If we see a new idempotency key, we will assume that, oh, you are manually trying to do a new retry. You want your money to be deducted, we will deduct it. But of course, we should have checks behind the scenes that if, let's say, they are trying to make a booking for an already done booking, that should not happen, right? So we can do some checks like that. But idempotency is solely for your retry purpose, that by mistake you retried because you were not able to receive a response. For example, a situation like this, when you were expecting a notification, but you have not received a notification and you immediately retried somehow. So your money should not be deducted twice. Now, what's our expectation here? That let's say if there is any piece of code, and there is any slight chance that this piece of code is expected to run only once, but might expect more than once. Due to anything, due to your own server side logic issue, maybe some kind of client retry, anything. What we have to do is, we should definitely bind this piece of code in a layer such that it becomes idempotent. And to be very honest, there is a very easy mechanism to actually make your API idempotent. What actually you do is, inside your request headers, there is a lot of information that comes up about an HTTP request. Along with this request header, you can actually send something called as a idempotency key. X idempotency -key, right? You can actually send a key like this, and the value of this key is going to be a unique idempotency key, right? Now, in order to generate this unique idempotency key, what you can actually do is, you can maybe have some random generator, right? Or maybe some kind of random logic that you are going to write in order to generate this idempotency key. That is technically somehow unique for every transaction or every API request. And this idempotency key, we are going to send along with the request header. Now on the server side, when we are going to receive our HTTP request, we will first of all verify that whatever storage we are using to store the idempotency keys, is this idempotency key already stored there or not? If we found out that this idempotency key was already stored in our storage, then we will not allow the request to go through. Otherwise, if this idempotency is not available, then what will happen is, we will start executing the code. If let's say the code goes somewhere wrong in between, then we will not do anything. But if let's say the code executes successfully, then at the last, inside our storage, we are going to store this idempotency key. So that next time when a retry comes up for the same transaction or for the same API, which has been successfully applied once, and we don't want its application again, then we will return directly from this check. As simple as that. As simple as that. And it will be the duty of our client to send us an idempotency key. If we are not receiving any idempotency key, then also we will not allow the request to go through, right? That's the overall mechanism that we need to somehow implement, right? And this is going to be pretty simple to implement. inside our request object for the Express application, we have a piece of concept called as request headers. Inside request header, we have the access to all of the headers. And for our backend API testing, we can directly send headers through Postman. So all you have to do, you have to send a idempotency key, like X idempotency key. Technically, you can keep any name. It's not mandatory that you have to keep the name as X idempotency key, but generally you will find people actually doing it, right? And then you can actually send the corresponding key on the backend. If let's say you are writing some client side code and you want some logic to generate a new idempotency key, right? What you can do is there is a package called as UUID, right? I'll show that to you. So you can actually generate a UUID, right? So let's talk about what is UUID. There is a package that you can install, npm install UUID. Okay, let's open it in a new tab. You can see there is a whole package out of it. And if you Google about what is UUID, you can see it's a universally unique identifier. It's some kind of a unique identifier that is used a lot of times in computer system. So what you can do, you can just use a package of UUID and then you can actually generate a new UUID. That's it. That's all that you have to do. This kind of a UUID you will get, and this kind of a unique token you can actually use. Now you might be thinking, where should we actually store our idempotency key? Now you can store the idempotency keys in your databases, but I believe retrieving data from the databases takes some time. So you can actually take a faster DB implementation that is a lot of time implemented in the form of a cache. We'll talk about caches later. So you can actually use a cache like Redis and store your idempotency keys in that cache. Or for simpler implementation, you can actually make a in-memory object, right? Something like a normal JavaScript object, and inside that object, you can actually store your corresponding idempotency keys, right? Now you might be thinking that if the server goes down, this object will also be down. Yes, that's a drawback, but this is going to be a fairly simple implementation to go. So in order for demonstration purpose, I will use the in-memory object, but again, you can actually implement your own cache, or maybe you can have a database table that you can refresh after every 2 or 3 days, that whatever are the old idempotency keys, you can actually remove all of them so that they become a bit reusable, but although every time it will be unique, right? And that's all that we have to do, right? So in order to make our make payment API idempotent, what we should do is, let's go to the controller. Now here, before we actually move forward with the logic, I'm going to say that const idempotency key is equals to request.headers x idempotency key. Okay. If this idempotency key is not present, or let's make our storage. Let's have a storage, right? InMemory DB, which is going to be just a JavaScript object, right? What you can say is that if the InMemory DB already has the idempotency key, in any of these cases where you are not sending the idempotency key or your in-memory database is having an idempotency key, in both of these cases, you are going to send a response like this, that is bad request. Okay, we'll send a bad request, and inside the JSON we will say let's say message cannot retry on a successful payment, right? That's it. Cannot retry on a successful payment. And otherwise, if the payment is successfully done, then what you are going to do, it's kind of like a dynamic programming logic, if you will carefully realize. Then inside your in-memory database, we are going to make an entry. I'll keep the key value pair, both of them as same. You can also keep a set if you want. And that's it, right? That's it. It's kind of like a memoization stuff. Now, let's see if the servers are up. No, the servers are not up. Let's say you try to make a payment. Okay. So let's go to make payment. Make payment, right? For this booking ID, let me make the status cancelled or status initiated. So let's start from bookings. So this is what, fourth booking. I'll say update bookings, or let's create a new booking. Let's not go in this much hassle. Let's create a new booking. We got a new booking with booking ID 5. Let's make a booking for booking ID 5. Booking ID 5. And now if you send it, you can see currently I am not sending the idempotency key. If you send it, cannot retry on a successful payment. This message is not that good, because if you are not sending the idempotency key, then you should specifically mention that. So let's have if not idempotency key, then you should say idempotency key missing. Okay. Let's send it again. Idempotency key missing. Otherwise, if you send an idempotency key, and for the time being, I am just going to send some random string altogether. Right. If I send it, see, the request successfully got completed. If you check the bookings, the booking is booked. If you try to retry, cannot retry on a successful payment. So any retry of this particular idempotency key session is not going to work for us. And hence we have made our APIs idempotent. So I can also show you this on Google if you want to read more about idempotent APIs. Idempotent APIs. Right. In context of REST APIs, when making multiple identical requests has the same effect as a single request, that REST API is idempotent. See, I'm making multiple requests, but I cannot modify the booking more than once. When we designed REST APIs, we must realize API consumers can make mistakes. Consumers can write the client code in such a way that there can be duplicate requests, right? For example, if you see Axios package, there are retry mechanisms that you can actually do for Axios, right? See, there is a Axios retry package as well, right? Using which you can actually implement a retry mechanism, or you can say retry in React API call. Let's see, you will find a lot of examples. See, they are using a fetch based on a retry, that if something goes wrong, you are going to do a retry. And that actually happens a lot of times. There are a lot of client implementation where we have to do retries, that okay, once this was not, we were not able to go through, maybe we can try again. These duplicate requests may be unintentional as well as intentional sometimes. Example, due to timeout or network request. Now timeout is a situation that can happen. For example, if let's say you make an API request, it actually processed everything, but it took too much time and we have timed out. There is a timeout that you can set up. In that kind of a case, a duplicate request might come up. In order to make our API fault tolerant, so that duplicate requests do not leave the system unstable, you make the API idempotent, right? And how do you make the API idempotent? Let me show you. So if we follow REST principle in designing our API, we will have automatically REST APIs for get, put, delete, head, options, and trace methods. If you use these kind of methods, these methods are automatically idempotent. You don't have to manually put a idempotency implementation. Only post APIs will not be idempotent, right? See, all of the others are going to be idempotent. Now, how do you make an API idempotent? How to make a post request idempotent? See, list of idempotent REST methods, list of non-idempotent. So post as well as patch. Patch is also non-idempotent. That was also written in the previous doc, right? So you can see what we are sending. We are sending kind of like a idempotency key in the header. This is what we are going to actually send, and we will keep a check on the other side. So you can read more about idempotency keys, but this is a very interesting engineering problem that actually comes at a lot of times in a lot of code implementations when you expose your APIs, but your APIs are not consumed in the proper fashion on the front end. Then you will always expect an idempotency key that I don't care how you have implemented stuff. Give me an idempotency key. Based on that idempotency key, you are going to make a corresponding logical upgrade, right? Apart from that, you might feel that, okay, the client might start sending any idempotency key. Then you can actually define a particular specific regex so that user do not misuse this idempotent APIs. You can specifically define a particular regex that my idempotency key is always going to follow a regex. That regex will be only known at the server side. So your end user won't be able to figure out, and you can keep a pretty complex regex. They won't be able to figure out that how they are actually implementing stuff, right? Or you can use a SHA-1 hash, right? Every time that the user won't be able to directly generate or something like that. So there are multiple ways to achieve this thing, but I believe the concept of idempotent APIs is clear to everyone.